We will now continue with section 4.2, discussing synthetic division. Our procedure table for synthetic division says, step 1, if the divisor is x minus k, write down k, followed by the coefficients of the dividend. Step 2 is to write the leading coefficient of the dividend on the bottom row. And then step 3 is to multiply k by the value placed at the bottom and place the product in the next column in the second row. This is easiest illustrated through an example. Our example reads, for each polynomial p below, divide p by x minus k using synthetic division. Use the result to determine if the given k is a 0. If not, determine p of k. So we'll begin with part A, which asks us to divide p of x is equal to negative 2x to the fourth plus 11x to the third minus 5x squared minus 3x plus 15 by a k value of 5. So as we set the problem up, we are going to place the k value on the outside of our division problem. You can see that that has been done here. We're then going to place the coefficients underneath. So we'll have negative 2, 11, negative 5, negative 3, and 15. Again, you want to ensure that every power of x is accounted for. So 4, 3, 2, 1, and nothing. So again, coefficients will be negative 2, 11, negative 5, negative 3, and 15. So those coefficients will go here. Once that is set up, we'll take our first number, which is the negative 2, and we're going to drop it straight down. We're then going to do a sequence of multiplication and addition. So we're going to say 5 times negative 2, and we're going to write the result here. So 5 times negative 2 is negative 10. We're then going to add these two together. 11 plus negative 10 makes 1, and place the result underneath. We'll then continue with that procedure. So now 5 times 1 is equal to 5, and we'll add negative 5 and 5 makes 0. Again, 5 times 0 is 0. Adding in the column, negative 3 plus 0 is negative 3. And then 5 times negative 3 is negative 15. And we add and get 0. Now, the way that we interpret this is that the number at the very end is your remainder. The other numbers make up the coefficients in your quotient. So if we are dividing, and we'll go back to the problem for a second, our polynomial function, which is a negative 2x to the fourth, then when we divide out, we're going to start this with 1 less in terms of a power of x. So our problem had an x to the fourth. This becomes an x to the third. So negative 2x to the third, because we're going 1 less, plus 1x squared plus 0x minus 3. Now, the question asks us, in addition, if the k is a 0. So if the remainder is equal to 0, then we can conclude that k is equal to 5 is a 0 for p of x. If the remainder had not equaled 0, then we would conclude that no, it is not a 0. Also, we can use this process of synthetic division to help us in factoring our original polynomial. So our original problem was the problem negative 2x to the fourth plus 11x to the third minus 5x squared minus 3x plus 15. Our first step in factoring that is to recognize that we do have a 0 at k is equal to 5, which means that x minus 5 is one of the factors when we factor our polynomial. Remember, we talked in the last section about there being a relationship between the factor and the 0. The other part of the factored version is what we got for our quotient. So negative 2x to the third, and I'm simplifying a little bit as I go, plus x squared. I'm going to leave the 0x out, minus 3. Now, this may not be completely factored, but it is at least one step towards having a factored form of our polynomial. All right, let's look at part B. Part B, we have to hold places for the missing x terms. So let's look back at our problem just for a second. We have an 8th power, a 7th power. We're missing the 6th power. So we're going to be inserting into this thing a 0x to the 6th, a 0x to the 5th, a 0x to the 4th. We have our x to the 3rd, x squared, x to the 1st, and 1. So when we do our coefficients for our problem, we're going to do 3, 9, 0, 0, 0, negative 1, negative 3, 1, and negative 1. And you can see that that's done here with those zeros inserted. The k value that we're dividing by is negative 3, and you can see that that's on the outside. And so that sets it up. We are going to drop this 3 down to start with, and then we're going to begin our process of multiplication and addition. So negative 3 times 3 is 9, and we add, we get 18. 3 times, I'm sorry, you know what? Negative 3 times 3 is negative 9. Let's get that right before we get any further. And negative 9 and 9 make 0. Negative 3 times 0 is 0. Adding, we get 0. Negative 3 times 0 is 0. Adding, we get 0. Negative 3 times 0 is 0. Adding, we get 0. Negative 3 times 0 is 0. Adding, we get negative 1. Negative 3 times negative 1 is positive 3. Adding, we get 0. Negative 3 times 0 is 0. Adding, we get 1. Negative 3 times 1 is negative 3. Adding, we get negative 4. So remember that that last term is your remainder. And so if the remainder is equal to negative 4, we know that negative 3 is not a 0. Remember that in order for it to be a 0, your remainder has to be 0. And so this also tells us that this doesn't help us in terms of getting this factored, because I don't necessarily know what happens outside of this remainder of negative 4. Synthetic division is going to be most helpful in the case where the remainder does equal to 0. But it does give us a quick way to do our long division, which is easier than setting it up with the x's. So again, our quotient would be made up of these terms. Since our original problem started with an x to the 8th, then when we write our quotient out, we're going to have x to the 7th, starting with 1 less, we'll have x to the 6th, x to the 5th, x to the 4th, x to the 3rd. This will be x squared, an x, and a number. Okay, so we can say that if we were dividing our original polynomial by x plus 3, that this would be our quotient. All right, so let's look at one more example of synthetic division. This one is a little more difficult. We have negative 3x to the 3rd plus the quantity 5 minus 2i times x squared plus the quantity negative 4 plus I times x plus the quantity 1 minus I. And we're dividing that by x minus 1 plus I. Okay, so let's look first at our coefficients and let's make sure that we understand what's happening here. We need the numbers in front of the x's. So we're going to get the negative 3. We're going to get the 5 minus 2i. We're going to get the negative 4 plus I, and we're going to get this 1 minus I. And so you can see these coefficients are written down on the problem. We don't need to hold any zeros because we have 3rd, 2nd, 1st, and nothing. So all that's good. All right, and we're dividing by x minus 1 plus I. Now, this is the first time we've seen this set up as a division problem. So I want to go back to our definition for just a second, and I want us to look at this. It says if the divisor is x minus k, then we're going to write down k on the outside. So notice that we're doing the opposite of what we have here. If we have a minus k, the k is going on the outside, not the minus k. So when we look back at our problem here, this is what we're subtracting. We're saying x minus 1 plus I. All right? And so we do need to do the opposite of that. So we need the opposite of 1 plus I. And so the opposite of negative 1 is positive 1. And the opposite of positive I is negative I. Okay. Because the idea is that if I were to plug this in for x, I would want 0 coming out of that thing. Okay. So let's go ahead and work it. We're going to drop the negative 3 down, and we're going to multiply. Now, the multiplication is a little more tedious here. Okay. So I'm going to multiply negative 3 times 1, which gives me negative 3, and then negative 3 times negative I, which gives me positive 3i. And then I'm going to add. So the number part of this becomes 2, and the I part becomes I. So 2 plus I. Now I need to multiply 1 minus I times 2 plus I. And this I'm going to come off to the side somewhere and actually do. So we are going to FOIL it out. 1 times 2 is 2. Outside will be positive I. Inside will be negative 2i. Last will be negative I squared. So I have 2 minus I. And then this I squared, remember, is a negative 1. So I have 2 minus I plus 1. So I have 3 minus I. All right, and now when I add again, the number part, negative 4 plus 3 is negative 1. And the i's cancel out. And then 1 plus I times negative 1. Negative 1 times 1 would be negative 1. Negative 1 times negative I would be positive I. And when we add both sets together, we get 0. So now we know that x minus 1 plus I is a factor of the original problem. We know that the remainder is equal to 0. We know that the quotient is equal to, now remember you start with 1 less, so if we had an x cubed here, we're going to start with an x squared down here. So negative 3x squared plus 2 plus I times x, kind of working our way down, minus 1. And so this is our quotient. Remainder is equal to 0. And we know that x minus 1 plus I is a factor.